Hello, ladies and gentlemen. It is now time to begin reviewing for your final exam in Common Core Algebra 1. We are going to be using a series of videos created by your teachers in order to best review the different topics that we've covered throughout this year. Each video will focus on a couple topics, and we are going to be doing problems straight out of your review book. What we're going to do is tell you the page number and the question number, and then we're going to go and work through those questions with you through this video. Your job is to have your review book out to the page, open to the page and to the right question number, and be doing the problem along with us. Then when you come into class, we're going to be looking to make sure you did that. And then you're going to be working independently and with pairs of students on other similar review questions from your review book or other ones that we may provide for you. Our hope is that by reviewing the topics this way through the videos, you'll be able to do that at home. Just kind of remind yourself of what we've learned throughout the year and maybe different processes and different ways of solving problems. And then when you come into class, you can try some problems on your own. And if you get stuck, you'll have your teacher or a peer there to help you along. So we're hoping that this is a really effective way to review for your exam. All right, let's get started. Okay, we're going to begin with test number 3, which begins on page 46 in your review book. And we're going to go right to question number 6. So if you can go ahead and open up your review book and find question number 6, somewhere between pages 46 through 66. All right. Now that you're there, we're going to go ahead and read this multiple choice question and solve it together. Okay, it says, which domain would be the most appropriate set to use for a function that predicts the number of household online devices in terms of the number of people in the household? All right, so first thing I have to look at is that they're talking about domain. In any function, we have domain and we have range. Domain are the inputs in the function. Okay, they're the values that we put in, and then what comes out, what we're measuring or what we are calculating for, that's the range. So as I read this sentence right here, okay, it's a function that does what? Predicts the number of household online devices in terms of the number of people in the household. Okay, so the question is, what are we measuring or calculating for, and what are we putting in? Well, in this problem, it is clear that we are, in fact, we're predicting for the number of household online devices. Those are then the outputs. Okay, that's your range. Here, what we're putting in terms of, that's a huge hint. That in terms of, that tells us that that's what we're putting into the function. So in terms of the number of people, those are our inputs, which of course would be our domain. Okay, so it says which of these sets of numbers, all integers, all whole numbers, irrational numbers, or rational numbers would work to characterize the number of people in a household? Well, when I talk about the number of people in a household, you could have 2 people in a household, you could have 5 people in a household. I'm talking about whole numbers. I'm talking about positive numbers, okay? So as I look at these choices, right away I know that irrational numbers are going to be out of the question. Those are decimals, square root of 3. I wouldn't say I have square root of 3 people in a house. Rational numbers, well, rational numbers there are positive whole numbers in there, but rational numbers also include fractions and decimals. So nope, that's not going to work. Integers. Okay, integers is close, but integers are positive and negative whole numbers and 0. So that also will not work because you can't have negative people in a household. So then lastly, our whole numbers. And whole numbers, like we said, are whole numbers, and they also are defined as only the positive set of whole numbers. Okay, the next question we're going to look at is the very next question, number 7. And it says the inequality 7 minus 2/3 x is less than x minus 8 is equivalent to, and we have 4 different choices. So the most direct way to solve for this is to solve it algebraically. So I'm going to go ahead and write that out. 7 minus 2/3 x is less than x minus 8. And I think we've done problems like this. We might have even done this exact problem in the past. And the thing that makes students struggle the most is that fraction, that negative 2/3. So the idea with an inequality, when we are covering these problems, they are linear inequalities where we need to move our x's to one side and our numbers to the other. So students don't seem to have a problem with moving the 8 over and getting it our numbers on the one side. But where students seem to struggle is then moving that 2/3 x over. When you have a term that has an x, okay, whether it has a fractional coefficient or a whole number coefficient, you can move it to the other side just by doing the opposite operation. So the opposite operation here is adding 2/3 x. Now when I add 2/3 x to x, it's important to remember that x is really 1x. So now when I'm adding 1x and 2/3 x, I can go ahead right in my calculator and add 1 plus 2/3, and you're going to see that you get 5/3 x. Okay, so then those are gone, and I have the 15 on this side. Okay, now I know that we've gotten pretty good throughout the year at remembering that when I want to get rid of a fractional coefficient, the easiest way to do that is to multiply by the reciprocal. So the reciprocal of 5/3 is 3/5. It's just when you flip the fraction. So you're going to multiply both sides by 3/5. When you do that, on this side, on the right-hand side, the 3/5 and 5/3 cancel, and so all that's left is that x. And on the other side, we have 3/5 times 15, which when you type in your calculator is in fact 9. So we end up with this answer. Now we want to be careful which choice. Clearly we're looking at either choice 1 or choice 3. But which one of those is correct? Well, if you notice here, if I move my x to the left-hand side like it is in the two choices, the inequality sign is open up to the x. So I want to make sure that I choose the one where the inequality is open to the x and pointing at the 9, which would be choice 1. Okay? Now another option for how to solve this on the exam is to look at your choices and to kind of think through the numbers that would work for each of those choices. And we've talked about plugging in different values in a multiple choice question, kind of plugging them into the equation or inequality that's given to you and see which one works. So if I look here, there are certain numbers that might overlap and work for multiple, and that's the only thing you have to be careful about with inequalities. Okay, so if I start with the very first choice and say x is greater than 9, if I choose a number bigger than 9 and plug it in to the inequality, it should work. So when I plug in, say, the number 12, okay, that is a number that's bigger than 9. If I did 7 minus 2/3 times 12, is that smaller than 12 minus 8? So when I type the left-hand side into my calculator, I get -1 on the left-hand side is less than 12 minus 8 is 4 on the right-hand side. So is it true that -1 is less than 4? Absolutely, that is true. Okay, well, before we just jump to choice 1 being the right answer, we should make sure, is that true for any of the other choices? Well, it's definitely not true for choice 3, okay? 12 is not a number smaller than 9, and it's not true for choice 4. So that did eliminate 2 of our choices. Now look at choice 2. All right, x is greater than -3/5. Well, is there a number bigger than 3/5, bigger than -3/5, other than 12, but that isn't bigger than 9? So say 0. Right? 0 is bigger than -3/5, but it's not bigger than 9. So if I wanted to verify and just kind of make sure that in fact it is in fact choice 1, I could test another number in, like here I'm testing in 0 and seeing if that works. Well now, and 0 is always a nice one to use, 7 minus 2/3 times 0 is 7. Is less than -8. Is that true? And definitely not. So therefore I know that that is not a correct option. So that's just kind of a guess and check way to do it, or plugging in different options. If algebraically you get stuck, what we don't want you to do is just skip over or guess on a question. We always want you to have multiple different options for how you could solve an inequality. So that was our second way to give you. Okay, we're going to move on to number 9, still on that same test. Somewhere between pages 46 and 67, I think. So which function has the same y-intercept as the graph shown below? All right, so taking a look at this, we have to first of all know what the y-intercept means. So the y-intercept is where the graph crosses the y-axis. So we can see that that happens right here, and this one has a y-intercept of -3. So we're looking for a y-intercept of -3. Now I just want to remind you, if we are looking at equations of lines, which all 4 of these choices are equations of lines, that means that we are looking at the standard form for the equation of a line, y equals mx plus b. So just a little review here. In order to read the slope and the y-intercept of a line, your line does have to be in y equals form. The number in front of the x, okay, the m value here, whatever number is stuck to the x, that is the slope. And then the number, the constant that's by itself, that is the y-intercept. So we're looking for a -3 to be the constant in our choices here. So if we look here, we have 4 different choices, none of which are in y, well, I correct myself. Choice 1 is in y equals form, but it's not the way we usually see it. The other 3 are not in y equals form at all. So we have to kind of take them and get them into y equals form and have them the way that we like to see them. So this first one I know has thrown students off in the past because it's y equals and you have a 12 minus 6x in the numerator and 4 in the denominator. Well, we've talked about this actually when we simplify using the quadratic formula. If you notice that you have a number that can divide into both terms in the top, in the numerator of your fraction, then you can go ahead and divide that into both of them. So this would be like writing y equals 12 divided by 4 is 3 minus 6 over 4x. So clearly our constant here is 3, not -3, and therefore that is not the right choice. Okay, moving on to choice 2, 27 plus 3y is equal to 6x. Okay, so I just scooched it up a little bit so I could get this in y equals form. All right, so this is good practice. 27 plus 3y is equal to 6x. I want to get my y term by itself. So that means I need to move anything that's with it onto the other side. So I'm going to subtract 27, which is 3y equals 6x minus 27. Then I'm going to go ahead and divide by 3. And as I'm doing it, I'm going to recognize right away 2x minus 9. So again, my constant here, my y-intercept, is -9, which is not what I'm looking for. So again, we're going to cross off that option. All right, moving on to choice 3, 6y plus x is equal to 18. Again, I'm going to take that, and I'm going to get the y by itself. This time, the term that's with it on the left-hand side is an x, so I just have to subtract x to both sides. So I get 6y is equal to 18 minus x. Divide by 6, and when I do that, I get y is equal to 3 minus x over 6, okay, or 1/6x. I actually know that we've talked about this lots, and I know Mrs. Hennessy has as well. When you are dividing x by 6, I would actually like you to write that as 1/6x, so you recognize the slope. Okay, so in this case, again, we are looking at that y-intercept, which is the constant. 3 is not our -3 that we're looking for, so choice 3 is also not right. Which leaves choice 4, so we're crossing our fingers that that's the right option, okay? If I look at choice 4, again, I have a number with the y on the left-hand side, so I simply have to subtract that 3 over. So in one step, I get y by myself, 6x minus 3. And now if I'm looking at my constant, that -3 is in fact what we were looking for, and so choice 4 is in fact the right answer. Okay, we're now ready to go to page 67 to 89, which is test number 4 in your review book, and we're looking at question number 4. Which table represents a function? So I think it's super important that we remember the definition of a function, which I now have on your screen. A function occurs when each element of the domain is paired with exactly one element of the range. What this means is that each x can only be paired with one y. Remember, domain are the x's, range are the y's. And so that means your x values cannot repeat with a different y value. That's the main thing. So this is something that you definitely learned in 8th grade, and we reviewed it this year. You're usually pretty good at recognizing this. Choice 1, if I'm just quickly glancing at my x's because I see those repeat of x's with different y's, that is not an option. Okay, looking at choice 2, 0, -1, 0, 1. Again, I have two different x's with two different y's, so that's not an option. Choice 3, looking at my x's, 3, 5, 7, 9. They are all different. It doesn't even matter what the y values are. That is your function. Okay, the next one we're going to look at is number 8 on test 4, and it says, which statement is not always true? You can see I've added some little notes for you, and maybe you want to copy those down, or this would be a great thing for you to commit to memory. There are times when we're asked questions about rational and irrational numbers, and we are given the actual numbers. Those are the best, because then we can just type them into our calculator, and you've gotten very good at recognizing rational versus irrational numbers, decimals, in your calculator. Remember that rational numbers are numbers that can be written as a fraction, and decimals that either terminate, stop, or repeat, go on and on forever, but with a repetitive, predictable pattern. Irrational numbers are numbers that cannot be turned into a fraction. They are numbers that are oftentimes square roots of non-perfect squares, or numbers with a pi in them. So those numbers, looking at them as a decimal, will go on forever and ever with no predictable pattern. Okay, so when you're looking at a question like this one, though, we have to just know. They are asking you which is not always true. And they're asking about adding or multiplying a mix of rational and irrational numbers. So you need to know that the sum of two rational numbers is always rational. And my little key down here, R stands for rational, I stands for irrational. Not super creative, okay? And you can see here, sum means to add. So if you add two rationals, or if you multiply two rationals, as these two are showing right here and here, you are going to get back a rational. This is always true. Number 2. The product of two irrational numbers is irrational. Okay, product means to multiply. So when you multiply two irrational, do you always get a rational back? Okay, or it says which one is not always true. So is it true that you always get a rational back, or do you not always? Well, looking at this, you have irrational times an irrational can be irrational, or you can also say irrational times an irrational is rational. Both of these conditions can happen depending on what two irrational numbers you multiply together. For that reason, this one is not always true. You don't always get back a rational. Looking at the next two just quickly, the sum adding of a rational and irrational, so that's rational plus irrational, is irrational. That's always true. The product of a non-zero rational number and an irrational number, so rational times irrational, is always irrational. Okay, so you might want to jot these down and memorize these. This is the one that they are going to test on a lot. Okay, that when you multiply two irrationals, sometimes you get irrational, sometimes you get rational back. And the quick way just to kind of prove that to you very quickly is by showing you, if I multiply, say, root 3 times root 5, those are both irrational numbers, I would get root 15, which is in fact irrational. You can check that in your calculator. But if I multiply root 3 times root 3, I'm going to get square root of 9, which is in fact 3, which is rational. Okay, the last one we're going to look at today is number 19 from test 4. The distance of a free-falling object has traveled can be modeled by the equation d is equal to 1/2 at squared, where a is acceleration due to gravity and t is the amount of time the object has fallen. What is t in terms of a and d? So we are being asked to solve for t in terms of, meaning a and d will be on the other side of the equation. So we want t alone, and we want a and d on the other side of the equal sign. Okay, so that's what this is telling us. All right, so that means I need to get t alone. Well, we've done a lot of these. If I notice that I have everything multiplying on the one side, 1/2 a and t squared, they are all multiplying. First thing I want to do is undo and get rid of the things that are stuck to the t. So I have a 1/2 and I have an a. Well, 1/2 is a fraction. If I have a fractional coefficient, we actually talked about this earlier in the video, I'm going to get rid of it by multiplying by the reciprocal. So the reciprocal here is 2/1, which of course is just the same as 2. That's going to allow me to cancel out the 1/2 on the right-hand side, and so I'll get 2d on the left equals what's left is at squared. Next step is to go ahead and divide away that a from both sides. Okay, so now I'm left with t squared equals 2d divided by a. Last step, I just want the t, I don't want t squared. And so I have to undo the squared. And the way that I undo the squared is by taking the square root. They are inverse operations. So I take the square root of both sides, and I'm left with t equals the square root of 2d divided by a, which of course is choice 2 here. Okay, thanks so much for listening and for taking these notes down in your review book and doing these problems with us. We'll see you in class.